y equals e to the x. This is one of the most important functions in calculus. In fact, we call it the function that calculus made because it's a function that comes from limits. So, how do we find the derivative of this function? Well, this is where we see one of its most beautiful traits. All right, and so if we use logarithmic differentiation here, we can rewrite it like this. Take the log of both sides. Then we've got these properties of logarithms that tell us we can bring that x down here. And now we have the natural log of y equals x times the natural log of e. If we go ahead and take the derivative now, take the derivative of both sides, we're going to use some implicit differentiation. We get this. Here we got to take the derivative of implicitly of the left side. So the derivative of the inside is y prime, or dy dx, all over y. Okay, that's our rule for logs. Now here, the natural log of e is just a constant. In fact, it's a special constant. The natural log of e is 1. So that's just 1. So this is just the derivative of x, because this whole thing is 1. And so 1 times the derivative of x is 1. So if we multiply both sides by y, we end up with this amazing result that the derivative of y with respect to x is y. Well, what does that mean? Well, the derivative, what was y? Y was e to the x. So we just found out that if y equals e to the x, then dy dx is also e to the x. Amazing. So this is the one function whose derivative is itself. When you take the derivative, it does not change. Every other function changes. So that's how we find the derivative of e to the x. And if we have the chain rule, e to the u, some function of x, then we've got to do a chain rule, derivative of the u, which is u prime, times e to the u there. Okay? So let's try that out. What if we have, we're going to find a derivative of y equals e to the x squared plus x minus 3. Well, dy dx, the derivative, is going to be the derivative of the inside, which is that exponent, 2x plus 1, times the derivative of the whole thing. Well, remember the whole thing is that it doesn't change. E to the u is e to the u times the derivative of u. So x squared plus x minus 3 in the exponent. And this is obviously exactly what we started with, and that's the whole point. The derivative of e to the x is e to the x. The derivative of e to the u just means we need to do the chain rule. Well, how about one more? What if we compose it with a sign maybe? Well, we've got to do dy dx, which means take the derivative of the inside. What's the derivative of the inside? Well, the inside's e to the x. What's the derivative of e to the x? It's e to the x. That's the derivative of the inside times the derivative of sine, which is cosine of e to the x. All right, so the derivative of e to the x is e to the x. Well, what if we have another base like 2? Well, if we have another base like 2, we've got to use this property that any number can be written as a power of e. Okay, so if we have e to the natural log of 2, let's think about that for a moment. What is e to the natural log of 2? Well, the natural log of 2 means that represents a number. The number that the natural log of 2 represents is the number, or the exponent, that you can put on e, the base, to get 2. I don't know what the natural log of 2 is, but it's a special number. It is the power I can put on e to get 2. So whatever that number is, let's just say we went ahead and took that number, the number that I can put on e to make it into 2, and I go ahead and put it onto e. Well, once I put it on the e, it serves its purpose. Its one goal in life. And its one goal in life is to make e into 2. So e to the natural log of 2 is 2. All right, well, we didn't have 2 here. What did we have? We had 2 to the x. So we have 2 to the x, or e to the natural log of 2 to the x. All right, and here we got a power to power. So power to power, we can write as, we can multiply, right? X times the natural log of 2. So with that, we're going to go the long way right now. Then we're going to discover the amazing shortcut. So 2 to the x is just, as we just wrote there, e to the x times the natural log of 2. So y is e to the x times the natural log of 2. So we've got this natural log of 2 hanging out, which, by the way, natural log of 2 is just a number. It's a decimal number. You can punch in a calculator to find out what it is. Well, let's go ahead and find dy dx. All right, dy dx. Well, this is e to the u. E to the u. So we got to find the derivative of the inside. What is the derivative of x times the natural log of 2? That's x to the first, by the way. And so that's just going to be natural log of 2. Again, that's just a constant. Times e to the natural log of 2 times x. Well, wait a minute. What was e to the natural log of 2? E to the natural log of 2 is 2. So this is natural log of 2 times, the parentheses becomes 2 to the x. And that's it. So what happened? When we take the derivative of 2 to the x, man, I wish it was as easy as e to the x. E to the x up here, that was easy. E to the x was e to the x. Well, it'd be nice if 2 to the x was just 2 to the x, but it's almost that easy. The derivative of 2 to the x is 2 to the x, but we've got to multiply it by this conversion factor. So really, you can think of this natural log of 2 as a conversion factor. And so there's our rule. Okay, since we remember that a is equal to e to the natural log of a, the derivative of a to the x is a to the x times the natural log of a. That's our conversion factor. That's the key. So you treat it the same way we would treat e, but then you need the conversion factor. All right, so how about this one? Dy dx. Okay. Well, if this was an e, it's not, but if it was, we would take the derivative of the inside. Derivative cosine is negative sine. And then we would just take the derivative of the whole, which for e to the x is just the same thing, right? 4 times the cosine of x. But we don't have base e, we have base 4. So we need to multiply that by the natural log of 4. Okay, we might write this a little simpler. Negative natural log of 4 times sine x times 4 to the cosine of x. Okay, there it is. All right, so that's how we take the derivative of e to the x and a constant or another number to the x power.